So hello friend, this is Kaustu Pathare again with a new video. Welcome to our channel Making Maths Easy. So in the last video we have solved the sums based on the logarithmic functions, logarithmic inverse trigonometric functions, logarithmic differentiation. So in today's video we are going to solve the sums based on implicit and explicit functions. So today we will start solving the derivatives of implicit function. You know what is the implicit function? So I will tell you what is the implicit function first of all, then I will start solving the sums which I have solved previously. In the previous video I have solved the sums based on logarithmic functions. Do you know the previous videos that I solved some sums based on the logarithmic differentiation where I use dy by dx. So that dy by dx is the implicit function. Any number with a combination of x and y is called an implicit function. So you can say in this case that if y is expressed as an implicit function of x, so y is an implicit function of x which is represented by the relation as f of xy equal to 0. So I have expressed one implicit function. Let's say consider as x y square. So x y square is my implicit function, and I have to differentiate this implicit function with respect to x. So differentiate with respect to x, or find a derivative, or find dy by dx with respect to x. So in short we can say that a implicit function is a combination of the x and y variables. In short we can say, or we can say that the implicit function if is a combination of two variables. Let's say if x is an implicit function of y, then y is an implicit function of x, and the relation between x and y is expressed as f of x comma y equation is equal to 0. Means f of xy is always equal to 0 in this case, in the case of implicit function. So if my x y square is equal to, which is equal to f of x, or f of x comma y, not f of x, f of x comma y, and this will be equal to, 0 in this case, because it is an implicit function. So x y square is equal to f of x y is equal to 0. So let's solve the function. So my x y square is equal to 0 in this case. So my x y square is equal to 0 in this case. So I will solve it, which is equal to 0. So we will differentiate, find dy by dx. In exam it will ask find dy by dx, and then we should think we have to differentiate with respect to x, using with respect to x, not we have to differentiate with respect to y. If it is dx upon dy, we have to differentiate with respect to y. If it is dy by dx, so we have to differentiate with respect to x. They will ask in this format, such as find dy upon d of x of, find dy upon d of x of the function. So you have to calculate finding, you have to start finding dy by dx. So find a derivative, so take derivative on both the sides in this case. So take derivatives on both sides in this case. So you will if you will take the derivative on both the sides, you will get dy by dx of x y square, dy by dx of x y square is equal to dy by dx of 0 in this case. In case of the implicit function where x and y are both are similar, or both are taken into the consideration, you have to take the derivatives, or you have to differentiate on both the sides, on the right hand side as well as on the left hand side. You have to differentiate on both the sides, because my x y square of is equal to f of xy, which is equal to 0. So we have to differentiate on both the sides in order to differentiate the particular function. So after differentiating on both the sides, we will get x into dy by dx of y square in this case, x into dy by dx of y square in this case, because u into v rule we are using over here, and then y square into dy by dx of x, which is equal to 0 in this case. So my derivative will be equal to x into the dy by dx of y square. The derivative of y square with respect to x will be 2y dy by dx. So it will be 2y dy by dx in this case, plus y square into derivative of dy by dx of x, or d upon d of x will be 1, which is equal to 0 in this case. So now we have to differentiate, or now we have to take the derivative of the function. Solving this equation, solving this particular equation, we have to take the derivative. It looks like a differential equation. It is same as a differential equation. It is basically a differential equation. So because x is an implicit function of y and y is an implicit function of x, so it is an implicit function in this case, and f of x comma y is equal to 0 in this case. So it will be x 2y dy by dx, x 2y dy by dx is equal to minus y square, because I have taken the y square, this y square value on the right hand side, so it will become minus in this case. If I have taken on, if I have kept it on the left hand side, it will be as it is, it will be plus, because I have taken on the right hand side, I have changed the sign values. So in this case it will be minus y square. So now we will solve it. So now my dy by dx, or the derivative in this case, will be equal to dy by dx is equal to minus of y square upon 2xy, y square upon 2xy in this case, as y square upon y I have in the particular function, so I will cancel one y in this case, so it will become y minus y upon 2x. So in this way you have to solve the rest of the sums in the differential equation of an implicit functions. So we have solved the sum based on the implicit function or derivative of implicit function. So let's solve some more sums based on the derivative of implicit function. So we have x plus square root of xy plus y equal to 1. So we have to take the derivative on both the sides. So after taking the derivative on both the sides, we will get d upon dy, or d upon d of x of this particular function, uh, and which is equal to d upon d of x of 1, as we know that the derivative of 1 is always equal to 0, because the derivative of constant is 0 in this case. So we will solve it further. Now we have to take the derivative of these functions, so express this function individually in this case. So first take the derivative of x, then take the derivative of square root of xy, then take the derivative of y, and finally the derivative of 1 is 0. So in this way you have to express it. So my derivative of x will be equal to 1, as I am differentiating with respect to x, and my derivative of square root of xy will be, first I will differentiate the root function, then I will differentiate the xy function. So my derivative of xy will be 1 upon 2 root of x in this case. So it will be 1 upon 2 square root of x, square root of xy in this case, and then I will differentiate the xy function. So d upon d of x of xy functions in this case, and then I will differentiate the y function. So I am differentiating the y function because y and x are both are implicit function if and only if f of x comma y equal to 0. So in order to differentiate or find a derivative of y function, it will be same. So it will be no change in the y function, as the derivative of y with respect to x is 1 multiplied by dy by dx. So it will remain dy by dx as no change in the y function. So it will be dy upon d of x, which is ultimately equal to 0 in this case. And then we have to differentiate the rest of the functions. So for differentiating rest of the functions, we need first, we have to differentiate this xy function. So 1 plus 2 into 1 upon 1 upon 2 square root of xy, we have to write it as it is, and then we have to differentiate xy function. So differentiating xy function will be x into the derivative of y plus y into the derivative of x in this case, because we are using the UV rule. We apply the UV rule over here in order to differentiate xy, u into derivative of v plus v into derivative of u, as we use the UV rule for differentiating. So y into the derivative of x into derivative of y plus y into the derivative of x, in this case dx upon dy, sorry, dy upon d of x, dx upon d of y, dx upon d of y. So, and plus dy by dx in this case, because this is left, which is equal to 0. Now we have to express it in the terms of dy by dx. For expressing it in the terms of dy by dx or differential equation, first we have to write this all, and we have to open the bracket, and then we have to simplify it. So first will be x into the derivative of, means dy by dx, as we are differentiating with respect to y, so there is no change, as I did over here. Differentiating with respect to y is no change. The derivative of y will be 1 into the dy by dx, so the same I have taken over here, plus y into the derivative of x. The derivative of x with respect to x will be 1, so there is no change. So plus dy by d of x, which is equal to, ultimately equal to 0 in this case, and then 1 plus, open the brackets in this case. So after opening the bracket, you will get 1 divided by, or x divided by 2 square root of x y, and then dy by dx plus y divided by square 2 into the square root of xy plus y divided by 2 square root of xy, and then after opening the brackets, you have to also write this dy by dx, which is also equal to 0. Now we have to express it in the terms of dy by dx. So for expressing it in the terms of dy by dx, we will get 1 plus y upon 2 square root of square root of xy, because we have to take the functions with the dy by dx and the functions without dy by dx as separate, because as we take in the complex numbers such as real part and imaginary part, the same thing we have to do over here. So we have to take the dy by dx terms, and we have to take the simplest terms, we have to separate the simplest terms, and we have to separate the dy by dx terms or derivative terms, or the terms adjoining with the derivatives. So I have taken these two terms, 1 and y divided by 2 square root of xy. So similarly also these terms I have to take on one side. So for taking it on one side, after taking this on the right hand side, it will become a negative in this case, because I am taking this particular function on the right hand side. So after taking it on the right hand side, it will be negative. So minus of, make a bracket and write dy by minus of x divided by 2 square root of xy dy by dx plus dy by dx, and then close the bracket. Okay, so now you have to take the dy by dx common in this case, in this bracket. Out of this bracket you have to take the dy by dx common in the next step, and then you have to solve the entire answer. So taking by dy by dx common in this case will give you the answer. So after taking the dy by dx common, you will get x divided by x divided by 2 square root of xy plus x divided by 2 square root of xy plus 1 in this case, and then you have to close it. Now you have to do one thing. Now you have to divide this and this. So take the minus sign inside, or you can keep it as it is, or you can shift the minus sign over here on the left hand side. So the final my dy by dx, or the final dy by dx will be equal to, so my dy by dx will be equal to, so I am writing here dy by dx. So my dy by dx will be equal to negative of or minus of. First I will use the divide operator here over here in order to differentiate. So negative, sorry, negative of this particular number means 2 square root of xy, 2 square root of xy plus 2 square root of xy plus y, uh, close the bracket, divided by x plus 2 square root of xy, divided by x plus 2 square root of xy in this case. So this will be my final answer. If you have a doubt how I got this answer, so you can take a test, or you can also verify the answer. So first, for verification, we have to first multiply this 2 square root of xy with this 1. So after multiplying 2 square root of xy with 1, we will get 2 square root of xy, uh, 2 square root of 2 square root of xy divided by uh, divided by 2 square root of xy, and then after taking this, that the denominator will be same, so I will get 2 square root of xy plus 1 plus y in this case. So I will show you. So it will be 1 plus, which will be equal to 1 plus square root of 1, or you can say 2 square root of x y divided by square root of xy in this case. So it will be 2 square root of xy plus y divided by 2 square root of xy, and which will be equal to this function. So it will be minus of dy by dx, so minus of dy upon d of x, and then this function, this 2 square root of xy will go in the numerator, and it will become, and it will become x plus 2 square root of xy, 2 square root of xy in this case, and then which will be divided by 2 square root of xy. Now one thing you have to keep in the mind, that this functions, or this particular function will get eliminated in this case, because we are dividing it, because if I multiply this, if I do the cross multiplication over here, so this x plus 2 square root of xy will come in the denominator, and this 2 square root of xy will come here in the numerator, and this will get divided with each other, and this will be cancelled in this case. So instead of this we can write 1, and instead of this we can write 1. So now the equation is balanced in this case. So this will go in the denominator over here, and this minus sign will come over here in this case, and as you know that we have got the final answer. So in this way you have to solve the more complicated sums based on implicit function or derivative of implicit functions. So if you like the video, please share, subscribe and comment on my YouTube channel, Making Maths Easy. For more videos related to mathematics, please subscribe my channel. Also like, comment and share my videos to your friends. So it will be help someone to score good marks in the mathematics. So thank you for watching.